So we've looked at integrating trig equations and functions in our previous theory video. What we're going to look at in this one, I'm going to set you a few questions on it. What I want you to do is read the questions, pause the video, have a crack at them, and then come back and check your answer against the working and the solutions that I've got and I'm going to do for you. Here are the questions. So I want you to integrate the following four trigonometric expressions. So the first one, f dashed of x equals 3 cos x. Second one, f dashed of t equals negative 2 sine t. The third one, dy by dx equals cos of 3x minus 1. And the fourth one, dy by dt equals sine of 3 over 2t minus a half. So what we have to do is pause the video just now, have a go at these questions, then come back and we'll go over the answers. So we're going to look at the solutions to these four questions now. So f dashed of x equals 3 cos x. So we want to get to the original function, so we know f of x is equal to the integral of 3 cos x dx. Now the big thing you need to remember about integrating trig functions is the negative sign. When we differentiate negative functions, cos goes to minus sine, sine goes to cos. Well, we need to flip that for integrating. So when we integrate, cos goes to sine, and sine goes to minus cos. So when we integrate this, cos, no sign change will occur, it's just the function. So f of x equals the integral of 3 cos x dx becomes 3 sine x. So f of x equals that. But again, something key we have to make sure we remember, include plus c. That constant of integration at the end has to still be included for trig functions as well. We've no limits at this point in time. That's what we have to make sure we include. The second one was f dashed of t equals negative 2 sine t. Now, a big difference in this one, again, is the change of variable. It's no longer x, it's t. But that doesn't change any of the steps that we do. It's still the exact same steps. The only thing that's different, you write a t instead of an x. Big deal. So again, we want to get to the original function f of t. We know that's going to be the integral of 2 sine t dt. Again, remember the dt tells you what variable you're integrating with respect to. So we take the constant, we write it down. We then have to integrate the sine t. Now remember, sine, because it's an integral, goes to minus cos. So that becomes minus cos t. We then have our plus c, our constant of integration. Now we simplify this bit here, and that'll be us all done. So we know f of t in this case equals, well, negative 2 times negative cos t. The two negatives cancel. I get 2 cos t plus c. Job done. That's my integration finished. So it's fairly straightforward. Just remember that we switch. Cos goes to sine, sine goes to minus cos for integration. So let's have a look at our next one. The third question I set you was dy by dx equals cos of 3x minus 1. Now remember, this was when we integrated cos or sine of the ax plus b. Now the only difference came into play when we had this bit here, because we had to make sure we divided by the coefficient of the x. Remember when we differentiated it, we changed this, write it out, and then times by the derivative in here. Well, to counteract that, in this case we have to divide it. So in this case we're dividing by the coefficient of the x. So we have to make sure we remember that. Now dy by dx equals cos of 3x minus 1. We know in this case y is going to equal the integral of cos of 3x minus 1 dx. So again, we're back to integrating with respect to x because that's the variable we have. So integrating cos x, so cos goes to sine, so it becomes sine of 3x minus 1. We then have to times it by 1 over the coefficient, so it's times by 1 over 3. The coefficient of x is 3, times by a third. We then have to plus c, and we can finish by simplifying it. We write our coefficient to begin with, so it's 1/3 sine of 3x minus 1 plus c. There we go, that's what we've got to be able to do. The final one that I set you was dy by dt equals sine of 3 over 2t minus a half. Again, same sort of thing, all I've done is change the variable. Is that going to add extra levels of complexity? Not if you're able to tell the difference between a t and an x. If you can do that, you'll be perfectly fine. So, to do this, we know we've got to take y equals the integral of sine of 3 over 2t minus a half dt. Again, this is what variable we're integrating with respect to. So we just have to take it from here, doing the exact same thing. The only difference is our final answer has a t instead of an x. Now remember, integral of sine, it's the opposite for taking the derivative. So the integral of sine in this case is minus cos of 3 over 2t minus a half. We then have to times it by 1 over the coefficient here. So it's times by 1 over 3 over 2. We then have to plus c. Now it's a case of simplifying. Once you've done that, Bob's your uncle, you're finished. 1 over 3 over 2 is the same as flipping the fraction and writing it like that. So instead of 1 over 3 over 2, that becomes 2/3, but it's minus. So we start by writing minus 2/3 cos of 3 over 2t minus a half plus c, a constant of integration. Integrating trig functions isn't overly difficult. The same general steps and ideas apply as to when we differentiated them. Yeah, there's one or two wee tweaks, one or two wee bits we have to remember, i.e. the dividing by a, so the 1 over a, but it doesn't change. The biggest thing that does change is just remember, instead of the way with derivatives where it's sine goes to cos and cos goes to minus sine, the negatives flip. So sine goes to negative cos and cos goes to sine for integration.